When you think about industrial cybersecurity, your mind probably jumps to things like firewalls, hardened controllers, maybe some complex tech. But what if I told you the most critical part of your defense has nothing to do with hardware or software? Today, we're digging into the human side of security, all through the lens of IEC 62443 Part 2. This is the part of the standard that's all about the policies, the procedures, and most importantly, the people that actually secure our critical infrastructure.
So let's just start with a really simple question. Your company, your plant, it's probably invested millions in top-of-the-line security systems. But can something as basic as 1 week, shared or, stolen password make all of that investment basically worthless? Could one simple human mistake bring the whole thing down?
The answer, and it's a big one, is yes. Absolutely. You can have the most advanced technical defenses in the world, but they can be completely sideswiped if the people running them aren't trained right, if the security policies are fuzzy, or if your actual day-to-day processes have holes in them. Technology is just one piece of a much, much bigger puzzle. And that is exactly the gap that IEC 62443-2 is built to fill. See, it's not a technical manual for a device. Think of it more like a strategic blueprint for your entire organization. It hands you the policies, the procedures, and the best practices you need to build a really resilient security program around the people who run your plant.
Okay, so here's our game plan. We're going to kick things off with the foundation, the Cybersecurity Management System, or CSMS. Then, we'll dive into the nitty-gritty of risk management for OT, tackle those critical operations like patching and incident response, look at the supply chain, and then talk about the huge importance of building a security culture. We'll wrap it all up with the cycle of continuous improvement.
All right, first up, the master plan. The Cybersecurity Management System, the CSMS, is really the heart of the 62443-2 standard. The best way to think about it is as the strategic defense plan for your entire industrial fortress.
Now, a CSMS is way more than just a binder that gathers dust on a shelf. It's a living, breathing program. It sets up the formal rules of the road for security, defining everything from high-level policies right down to the specific roles and responsibilities for everyone, from the operator on the plant floor to the engineer in the control room. And for those of you in the North American energy sector, yeah, this whole disciplined approach is going to feel pretty familiar, a lot like the ideas behind NERC CIP.
This table just perfectly captures the whole dynamic nature of a CSMS. It really boils down to 3 continuous loops. First, there's risk awareness. You have to ask, what could go wrong here, and just how bad could it be? That leads to things like asset inventories and impact ratings. Then you move to risk mitigation. Okay, how do we shrink that danger down to a level we can live with? That's where you get your hardening plans and new policies. And finally, and this is so important, performance refinement. Are our defenses still working? Where are the gaps? We answer that with metrics, audits, and roadmaps. It is a constant cycle, not a one-and-done project.
So, with that framework in mind, let's talk about risk. Because managing risk in an operational technology environment in OT is a whole different ballgame than in your typical IT office. Here, the stakes are physical.
So the key takeaway here is that the standard requires a formal, repeatable process for managing risk. This isn't about hunches or guesswork. It's about systematically identifying your threats, assessing their potential damage, and then putting controls in place to bring that risk down to a level your organization can actually accept.
And this slide says it all. In the IT world, a really bad day might be a data breach or losing some money. In the OT world, a bad day could mean the entire plant grinds to a halt. It could mean an environmental disaster, or worst of all, it could mean serious consequences for people's health and safety. The whole focus shifts from just protecting data to guaranteeing that operations keep running and people stay safe.
This brings us down to the plant floor, to the day-to-day realities of keeping an industrial facility secure. How do you handle something essential but also risky, like patching a system or responding to an attack, when you literally cannot afford any downtime?
I mean, this quote just hits the nail on the head, right? In the universe of industrial control systems, availability is everything. You can't just decide to reboot a critical controller while it's in the middle of a process. And that one constraint changes absolutely everything about how we have to approach security operations.
So, forget about the IT world's Patch Tuesday where everything gets updated automatically. OT patching is this careful, deliberate process. First, you're monitoring for vulnerabilities. Then, and this is critical, you have to check if the patch is even certified by your vendor for your specific system. Next, you test it, and test it again, in a lab environment.
Only then do you schedule a formal maintenance window to apply it and then verify that everything, and I mean everything, still works as expected. It's a slow and careful dance.
And it's the same story for incident response. The priorities are just different. Let's say ransomware hits a plant's HMI. The IT playbook screams, isolate the network, now. But in OT, the first priority is completely different. Can the operator still safely control or shut down the physical process? Job number one is always to maintain control and ensure human safety. Then you can worry about containing the malware and planning a controlled recovery.
Okay, let's talk about a risk that honestly gets overlooked way too often. Your partners. The security of your plant isn't just about what you do inside your own walls. It's also about what your vendors, your integrators, and your service providers are doing. This is a huge focus of the standard.
At its core, supply chain risk is the threat that a vulnerability gets into your system through a trusted third party. It could be the system integrator who's setting up new equipment or vendor who's connecting remotely to do some maintenance. Suddenly, their security posture has become a part of your security posture.
So what do you do about it? Well, IEC 62443 gives us a pretty clear playbook. You have to enforce strict access controls for any vendor. Only give them the keys they absolutely need. All remote connections have to be secured and monitored. You need to write cybersecurity requirements directly into your legal contracts. And finally, you have to have a process for checking the security of any third-party gear before it gets plugged into your network.
We've talked frameworks, we've talked processes, but now we get to what is arguably the most important and often the hardest part of this entire equation: building a strong security culture. This is all about making security everybody's job.
I want you to just let that sink in for a second. You can have the best tech money can buy and the most detailed policies in the world, but if your people don't get them, or they don't follow them, or frankly, they just don't care about them, your defenses are going to fail. The human element is the true foundation of all your security efforts.
Building this kind of culture isn't magic. It takes a deliberate approach. It all starts with basic security awareness for everyone. Then, you need specific, role-based training for people in critical jobs. Your procedures have to be crystal clear and easy to follow. And maybe most importantly, you need visible, consistent support from the top, from leadership that shows everyone that cybersecurity is a core value for the organization.
Finally, let's zoom out and look at the long-term vision. Look, implementing a CSMS isn't a project you do once and then check off a list. It's a continuous journey of improvement, mainly because the threats we face are always evolving.
And this really brings us full circle, doesn't it? The security lifecycle is this constant loop. You assess your posture with audits and reviews. You implement new policies and controls based on what you find. You constantly monitor your systems for events and track key metrics. And then, based on all that data, you refine and you improve your program. And then, the cycle starts all over again.
So, I want to leave you with this one question to think about. At your organization, do you treat security like a project, something with a start date and an end date? Or have you truly made it a continuous, living process that's baked into your company's culture? Honestly, the answer to that question makes all the difference. So, to wrap it all up, IEC 62443-2 gives us that essential human and procedural framework. It's the governance plan for our fortress. In our next explainer, we're going to build on this foundation and dive into part 3, where we'll look at the technical requirements for actually designing and building the walls and gates of that fortress. I'm really looking forward to seeing you there.